In this video, we'll be learning about unit rates. The way we define a unit rate is the ratio of two quantities that have a proportional relationship. Some examples include how much you make per hour, pounds per second if we're on like an assembly line, or sales per week if we're a salesperson. Before we get too far ahead, let's review fractions, units, and the properties for multiplication and division. All ratios, fractions or not, are simplified, raised, or used in equations as if they are fractions. And we're going to do this to help us decrease our confusion as we move through all different kinds of problems for units, unit rates, proportions, unit conversions, all of those things. We're going to try to keep that as close to the same strategies as possible. This means that we can solve problems just using units as if they're numbers. And in order to do that, we have to make sure we really understand the properties that govern fractions and ratios. For example, one of the few division properties we looked at was the division identity property, which said if we took any number, divide it by itself, it gives us 1. Same thing works for units. If we take inches and divide it by inches, or any other unit like oranges divided by oranges, we end up with 1, that those units will cancel out. We also talked about the multiplicative identity property, where if we have any number times 1, that is itself. So if we take inches times 1, we still have inches. But we also talked about the multiplicative inverse property, where we said any number times its inverse is equal to 1. So in this case, it would be inches times 1 divided by inches will equal 1. But something is really interesting here. The multiplicative inverse property gives us the division identity property. So if we have inches times 1 over an inch, remember all rational numbers can be written as a fraction. If they're a unit or a whole number, that means they go over 1, because any number divided by 1 is itself. And if we multiply straight across, we end up with inch over inch, which is that division identity property. But what would happen if we took inches times inches? Well, we would follow the exponent rules here, and we would treat each unit, so inch times inch, as being raised to the first power. The first power plus the first power would give us inches squared. Most of the time, though, you're going to see this written as square inches, and that abbreviation would look like this. Let's look at an example problem. In this example, we're going to be following a sports team called the Yellow Jackets. The Yellow Jackets travel on a charter bus from Anytown, Iowa to rural Michigan, a journey of 656 miles in 8.5 hours. The first thing to notice is that the answer should have a ratio of miles to hours, because we want to know the average speed. So the way I'm going to write this is, ooh, that's not showing up very well. Let's switch colors. We need to have an answer of miles over hours. And the only way to get that from the information needed, or that's given to us, is to take miles divided by hours. Miles is in the numerator position on both sides of the equal sign, and hours is in the same spot on both sides of the equal sign. We'll talk about that in more depth as we move forward. If we take 656 divided by 8.5, we get 77 miles per hour. But how could we visualize this example? In order to do that, we are going to look at data tables. Now we have to know how data tables are organized. Remember, if we go back to the first lesson in coordinate planes are set up with X and Y axes, and data is plotted with coordinate points, either positive or negative X, comma, positive or negative Y. So it would make sense to have an X and Y in our data table. So now how do we know which value is on the X-axis and which one goes on the Y? Since our data table is set up like this, one way that we can remember which goes where is that for any unit rate, so in this case miles per hour, the numerator is almost always your X variable, and the denominator is the Y variable. So let's go ahead, pause the video, create a data table for the previous example of the Yellow Jackets, where this is miles and this is hours. We'll start at 0, 0, and I'll give you the next coordinate point of 77 miles in 1 hour. Go ahead and complete this data table. Now that you have your data table filled out, it should look something like this. Coordinate points are written as X comma Y, so that means any of these pairs in a column is X over Y, so we would write that as X comma Y. That is our coordinate point. This will be 154, comma 2, 308, comma 4, 462, comma 6. And what we're going to do is we're going to use this data table and these coordinate points to sketch a graph. Because in the last slide, we saw that all of our coordinate points are positive, we're just going to look at the first quadrant where we have positive X and positive Y. Remember, this point right here is the origin where both sides are 0. Y-axis is hours, X-axis is miles. And just for the sake of saving space, I'm going to scale my X-axis as if each line represents the exact value we need. And then we're going to plot the points. I'm going to change colors. Here's 1 and 77. We had 0, 0, 154 and 2, And because this is a sketch, we're not going to get a perfectly straight line like we would see on a graph. But almost all of these points, not almost all of them are going to land on that line. So let's compare our sketch with an actual graph generated by the Desmos online graphing calculator. When we use this app, what we're going to do is we're going to press this plus button here, and we're going to change this to table. And then we're going to start typing in our points. Zero, 0, 77 and 1, 4 and 2, 5. And we're going to stop right there for now. The only point that we can see is 0, 0. And that's because the way this is scaled is that each of these darker lines goes by 2s. So let's zoom out. If we zoom out to everyone being 5, we still don't see anything. If we zoom out to 10 for a scale, we don't see anything. 20s, we see our first point out here at 77 and 1. There's our second point. Then our last point out here. Go ahead and pause the video and reflect about and compare how this is similar and different to the graph we sketched. All right, after thinking about it, both of our graphs, the one we sketched and this one, show a straight line. But how steep those are different. If we could scale this graph to be like the one we had, it wouldn't be so shallow or flat going across this x-axis. Okay, so it's relatively flat, but the one that we had looked more like this. And that's just because of how we chose to represent our data. But if we go back to how we defined unit rates, we said that unit rates were the ratio of two quantities with proportional relationship. And we see a proportional relationship in both the one we sketched and this one on Desmos. That proportional relationship shows that as our miles increase, so do our hours traveled. So both the x is increasing okay, x is increasing, and so is our y. Y is also increasing. And they are increasing at the same rate together. This side is always plus 77. This side is always plus 1. That relationship is not changing. Before we go, I want to go back to our slides and let's do some practice problems with unit rates. The way this works is I'm going to do a problem. I'm going to show you how to set it up and solve it. Then you are going to do the next one on your own. You'll pause the video and attempt it. At the very end, you will get the answers to all the UD problems and one last assignment. Oranges cost $2.40 for 1 dozen. How much will 1 orange cost? Now we want to know what 1 orange costs, but we're given that we have 1 dozen. We have to recognize that this is equal to 12 oranges. And we want the cost of 1 orange, so that means our unit must be cost per orange when we finish. We're going to take $2.40 and divide it by 12 oranges, and that will give us $0.20 per orange. Or, I mean, that's awkward to say. We just say it's 20 cents. For your problem to do on your own, a ham that weighs 6.19 pounds is cut into 37 slices. What is the average weight per slice of ham? Pause the video and attempt this on your own. Remember, the answers will be provided at the end. All right, now that we're back, let's look at another example problem. Christy picked 3,000 apples from her orchard and plans to make cider. 1 gallon requires 36 apples. What is the maximum number of gallons Christy can make of her cider? Let's look at the information we're given. We have 3,000 apples, and 1 gallon requires 36 apples. And we want to know the maximum number of gallons. So we need to end with just gallons as a unit. So let's take this in order. 3,000 apples. Because it's rational, I'm going to put this over 1. I want apples to disappear. Remember, I want to be left with gallons. And in order to do that, I need to get apples divided by apples. Remember, that is the division identity property. So that means 36 apples will go here, and 1 gallon will go here. Those units will cancel out. So essentially this problem is 3,000 divided by 36. That gives us the total number of gallons. And when we do this, it is approximately 38 gallons. And remember, on these answers, we want to round according to the significant figure rules that we learned earlier. So let's look at the next you-do problem. Franco Ferguson scored 84 points in 3 games. What was the average points scored per game? Remember, take a moment to pause the video, and the answers will be provided at the end. Here is the final I do problem. Caden Vane took a hike through a national park. His Fitbit showed 12.38 miles in 3.23 hours. What was his average rate of speed? This is kind of going back to the same lines as the yellow jacket problem, where we have miles per hour. So we're just going to divide 12.38 by 3.23. That is going to give us 3.83 miles per hour for its average rate of speed. Now for the final UDO problem. The website $6 Tees can print 8 shirts in 25 minutes. How long does it take to print one shirt? Pause this video, and the next slide will show the answers. All right, so let's go ahead and take a look at what the answers were for those 3 UDO problems. For the first one, we should have 0.17 pounds per slice of ham. The next one, we would have 28 points per game. And for the last example, we should have 0.32 shirts per minute. That's all for this time.